Hello, my geometry students. This lesson is on 7-3, inequalities within a triangle. And it actually begins in Braille on page 291 straight up, and in print on 291. On 290, it's an interesting topic about florists and flower arrangements, and then a graphing calculator exploration. But we're just going to jump right to the theorems on page 291. They're pretty basic, so this is just about making sure that you get your symbols in order. When you write up these inequalities, you're writing them in the correct order and using the right written code, written symbols, and the right Braille code. So the first theorem is on page 291, and it's theorem 7-6. And in words, it says, if the measures of three sides of a triangle are unequal, then the measures of the angles opposite those sides are unequal in the same order. And we discussed this earlier. We kind of used our deductive reasoning and started noticing this back in the previous chapters learning about triangles, where we started noticing, oh, you have the longest side across from the largest angle. You have the medium side across from the medium-sized angle, and you have the shortest side across from the smallest angle. So hopefully you remember that, but if not, this officially states it. And then it gives a graphic, and it shows it. So there is a triangle, and P is the top vertex at the right, and then L is the bottom vertex at the bottom right, and at the bottom left is M, and then we go back up to P. So there's the outline of a scalene triangle. And from M to P, they've labeled that 11 units. From P to L, they've labeled that 6 units. And from M to L, they've labeled that 16 units. And then using the words of the theorem, if the measures of three sides of a triangle are unequal, these are all unequal, aren't they? 11, 6, and 16. It's a scalene triangle. Then the measures of the angles opposite these sides are unequal in the same order. So if ML is the largest side at 16, the angle opposite is P. That's the largest angle. M to P is 11 units, so the angle opposite that side is L. That's the middle angle. And then PL is 6, and the angle opposite that is at vertex M, angle M, and that's the smallest angle. So down in symbols, below the drawing, it shows what's going on. It says PL is less than MP, which is less than LM. So it went from least to greatest. So therefore, it goes from least to greatest on your angles. The measure of angle M, which is opposite that PL side, 6, is less than the measure of angle L, which is opposite that 11 side, that MP side, the middle one, which is less than the measure of angle P, which is opposite your largest side of ML, which is 16. So then the next theorem on the next page, 291A, it talks about the converse, which is also true. So think about converses, right? We had the last theorem said if the measures of three sides of a triangle are unequal, then the measures of the angles opposite those sides are unequal in the same order. So the converse now, we're going to say, we're going to flip it around, aren't we? So we're going to put the hypothesis and the conclusion in opposite orders. So now this one's going to say, if the measures of three angles of a triangle are unequal, then the measures of the sides opposite those angles are unequal in the same order. So we say this front and backwards, so we cover all our bases. So you have another triangle, a model. W is the top left vertex. Immediately to the right is K. And then down at the bottom right is vertex J. That gets you back to vertex L. They shouldn't have put tick arcs in this drawing. The Brailleist or transcriber took liberty to do that. I think what they were trying to do is make a mark to point outside of the triangle to show you the measurements. Ignore the tick marks as congruency and just notice that they're letting you know above each above or to the side of each vertex its measurement. So at vertex W, right above it, it says 45 degrees. And at vertex K, to the right of it, it says 75 degrees. And at vertex J, to the right of it, it says 60 degrees. So notice that you have W is the smallest. At vertex W is your smallest angle. And then your next one would be J, at vertex J at the bottom right, 60 degrees. And finally, your largest one at vertex K at 75 degrees. So the converse of Theorem 7.6 now is Theorem 7-7 that says that you could put these angles in order and you can put the sides opposite them in the same order. So the side opposite vertex W is the smallest. Therefore, KJ is the smallest side. It's opposite the little 45-degree angle. The side opposite the next one, angle J, is 60 degrees. The side opposite is WK, so that's the next largest side. And then finally, the biggest side of the triangle is the side opposite the largest angle, which is angle K at 75 degrees, and the side opposite is WJ. So down in symbols, it shows how you would write these. The measure of angle W is less than the measure of angle J, which is less than the measure of angle K. 45 is less than 60 is less than 75. So therefore, the sides opposite would go in the same order. JK, the side opposite W, is less than side KW, which is opposite the 60-degree J angle, which is less than WJ, which is the side opposite K, the largest angle at 75 degrees. So you just have to really be good at writing these in the correct order, being very careful to put your angles in order and then your sides opposite in order, or vice versa. You put your sides opposite in order and then you put the angles opposite them in order. So the next example just goes through that practice of listing the angles in order from least to greatest. So it's not super hard math, it's just making them out on your graphic. So it says in triangle LMR, list the angles in order from least to greatest measure. So we have L at the bottom left, then go up to the top right and you have vertex M, and then the bottom right is vertex R. We back to L again. There's the outline of your triangle. From L to M, it's saying that's 21 inches. From M to R on the right, that's 14 inches. And from L to R on the bottom is 18 inches. So you know mathematically you can list these in order. Hopefully you've found the smallest, 14, and then the next one, 18, and the next one, 21. But they don't want it written in 14, 18, 21. They want you to write it, that the angles in the least to greatest order. So first you could write the sides in the order, and they show that. MR is less than RL, which is less than LM. And then you write the angles opposite. So MR is your side that's the smallest. The angle opposite, the one that doesn't include M and R, is L, isn't it? So angle L is smaller than the angle opposite your RL, which is M. So L is smaller than M, and the measure of M is smaller than R. So you'd say the measure of angle L is less than the measure of angle M, which is less than the measure of angle R. And that's how it talks about first write the segment measures in order from least to greatest, and it shows that. Then using the Theorem 7-6, write the measures of the angles opposite those sides in the same order. And on the next page, it shows writing the sides in order, and then directly below they show the angles opposite those sides, and they write those in order. The angles in order from least to greatest measures are angle L, angle M, and angle R. So in the your turn, it says in triangle DST, List the sides in order from least to greatest measure. So now they're talking about the sides, not the angles. And again, they have little arrows pointing into that kind of look like congruency arcs, but they're really arrows pointing into the angle measures, so be aware of that as we explore this tactile. You have angle D at the left, and you go up to the top right and you have angle S, and the bottom right you have angle T, and back to T again, so triangle DST. At angle D, at vertex D, it's 43 degrees. At vertex S, it's 58 degrees. It's saying that off to the right. And at vertex T off to the right, it's saying it's 79 degrees. And there's little light arrow indicators into those. They're not congruency arcs in this situation. So what's the smallest angle? The 43-degree one. But you wouldn't say 43 degrees. You'd say the measure of angle D, which is the next one. It's the 58-degree angle, which is angle S, or the measure of angle S. And finally, our largest angle is the measure of angle T. So you'd write out the measure of angle D is less than the measure of angle S, which is less than the measure of angle T, but that's not the final answer, and that very well could be a choice on a multiple choice test, but they didn't ask you to list the angles least to greatest. They want to know the sides. So you go back to your angle D, and your side opposite, directly across from it, is side ST. So that's the smallest side. So you'd say ST is less than, and you'd go to your 58-degree angle, angle S, and you go to the side opposite, which is TD. So you'd say is less than TD. And then finally, the side left over is DS. That's your longest side. That's the side opposite your 79-degree angle. So ST is less than TD, which is less than DS. You could write them in either order, right? Because these are sides and segments. You could write them SD. You could say TS, the smallest side, is less than DT, which is less than SD. Just make sure that you're grabbing the end points of each side and you're putting them in the right order. Okay? So there's a page break on the next page, which gets us to page 292. Print users, we have an example. It's called Surveying Link. It's a world problem. It says scientists are developing automated robots for underwater surveying. These undersea vehicles will be guided along by sonar and cameras. In triangle NPQ, if triangle NPQ represents the intended course for an undersea vehicle, which segment of the trip will be the longest? So the next page in Braille is 292A. There's a graphic, and it has a big arrow above it that says start. So let's just start showing the path. It's trying to represent a photograph in a book of an underwater robot doing its path. So in the top left corner is Q. Top left vertex is Q. Top right vertex is N. And bottom vertex is P. Then we're back to Q again. At vertex Q is a right angle indicator. So how many degrees do you know that is? You should be yelling out 90. At vertex Q, there's a little light arrow line pointing into Q, and it's saying that at vertex Q it is 48 degrees. And then at vertex N, there's a little light line indicator pointing into vertex N saying that that's 42 degrees. So you know all the measurements of the angles. Angle P, 90, at angle Q, 48, and at angle N, 42. So you can write those angle measures in order and then use your theorem, your converse theorem, theorem 7-7, to write the measures of the sides opposite in order. So you know the smallest angle is angle N. Therefore, the side opposite, you go directly across through your triangle almost like following a median, an invisible median, to opposite side QP. That's your smallest side. So that's the first one. Then 48 degrees at vertex Q is the next angle. So you go the side opposite, pretend like you're floating through the midst of your triangle, creating an invisible median to the side opposite is NP. That's the second in line. And And then finally, P at 90 degrees, vertex P at the bottom at 90 degrees is your largest. So the side opposite is QN. So you would state that PQ is less than NP, which is less than NQ or QN. However, what order you'd like to write those points in is your prerogative, but make sure the sides are in order least to greatest, right? And then and it shows that happening. It says first write the angle measures in order from least to greatest. So they write them. Measure of angle N is less than the measure of angle Q, which is less than the measure of angle P, and then they have little down arrows pointing to their opposite sides that are also in the same order. So the opposite side of angle N is PQ, which is less than the opposite side of angle Q, which is NP, which is less than the side opposite angle P, which is QN. Right? So then it says that Theorem 7-7 to write the measures of the sides opposite these angles is in the same order. So QN, the first segment of the course, will be the longest. So when you do that and you get them in order, then to answer the question back at the story problem, it says which segment of the trip will be the longest. So this is a lot of work shown. You probably could have just used the theorem, gone to the drawing and said, oh, my 90-degree angle is my biggest angle, so I know my side opposite is my longest side, QN. So then your turn, there's a story problem that's on the next Braille page, 292B. It says, if triangle ABC represents a course for an undersea vehicle, which turn will be the sharpest? That is, which angle has the least measure? A sharp turn means a very acute angle, so the smallest angle. So they give you this triangle, ABC. A is bottom left, B is top right, and C is bottom right. Back to A again. From A to B, they're saying 43 meters. From B to C, they're saying 45 meters. And from A to C, they're saying 51 meters. And the question is, which angle is the sharpest, which is the most acute? So that would mean the smallest. So find your smallest side. It's the 43 meters, correct, on AB. Directly opposite AB, kind of find the middle of AB and then float through the middle of your triangle like a median and go directly opposite to angle C. Angle C would be the smallest angle. And that's what you'd answer for this question, is angle C is the sharpest turn, the smallest angle. Let's turn to the next page, which illustrates Theorem 7-8 based upon what we just did in the last few story problems. It says in a right triangle, the hypotenuse of the side is the side with the greatest measure. And we discovered this back when we studied right triangles. The side opposite our 90 degrees is the hypotenuse, and that is always the longest side because the 90-degree angle is always going to be the biggest angle. Because as you learned a long time ago in right triangles, if you've got a 90-degree angle, the other two angles have to split up the remaining 90 degrees. So they will never be, they'll always be acute, and they'll never be more than 90. So any side opposite the 90-degree angle on a right triangle is always the longest side, and it's called the hypotenuse. So this shows the model of that. There's a right triangle. W is at the top left, X is at the bottom left, and Y is at the bottom right. There's a right angle indicator at vertex X. From W to X, it's saying it's 3 units. From X to Y, it's saying 4 units. And then if you use the Pythagorean theorem, 3 squared plus 4 squared should equal 5 squared. That's the measurement of WY, and that is directly opposite the 90-degree angle. If you go back to vertex X and you move through the triangle to the side opposite, you get to side WY. That side will always be the longest side, and it's called the hypotenuse. That's a little bit of review about right triangles and their rules and some vocabulary. So that's the end of section 7-3, inequalities within a triangle. It's pretty basic. It's just being very careful to keep the information in the right order, to really concentrate and think about what order that is, to move about your figure very very purposely from one angle to the side opposite, like create those invisible median lines to kind of keep you on track to find those sides opposite, or angles opposite the sides to keep them in the right order. I would highly advise doing the check your understanding, at minimum, at least number 1 through 8, but for extra practice, it would be good to do numbers 9 through 24 on pages 292 to 294. All right, everyone, do good thinking, and we'll see you in the next video.